All right, in this video, we're going to look at the differences between K, the equilibrium constant, and Q, the reaction quotient. So if I have a general reaction, right, reactants going to products, right, the equilibrium constant expression is the concentrations of the products divided by the concentrations of reactants. So K tells us whether a reaction is product favored or reactant favored. When we say product favored, that means there's more products present at equilibrium. If I say a reaction is reactant favored, that means that there's more reactants present when the reaction is at equilibrium. So to answer this question, I compare K to 1. When K is bigger than 1, that means I have more products than reactants, and we'd say the reaction is product favored. When K is less than 1, that means that the denominator here is bigger than the numerator, so I have more reactants than products, and we would say that the reaction is reactant favored. Now Q is what we call the reaction quotient, and it has the same expression that K does. It's the concentration of the products divided by the concentration of the reactants. The difference is it's only an equilibrium constant if I'm at equilibrium. So I can only plug concentrations into an equilibrium constant expression if I know that I'm at equilibrium. If I'm at any other conditions, then we call it a Q. We call it a reaction quotient. So they're really the same thing. It's just if I'm at equilibrium, I call it a K, an equilibrium constant. If I'm not at equilibrium or I don't know, I call it a Q and I call it a reaction quotient. But the usefulness of Q is it tells us what direction a reaction will go to get to equilibrium. So to determine which direction a reaction will go, I compare Q to K. So if Q is less than K, then the way I think about it is I don't have enough products, right? My numerator is not big enough. And so the reaction will proceed to the right. It will go from reactants to products. It will make more products. If Q is greater than K, that means I have too many products. My numerator is too big. So the reaction will proceed to the left. It will go from products to reactants to use up the products, make more reactants, and we will say that the reaction proceeds to the left. If I calculate Q and it's equal to K, then I know that the reaction is at equilibrium. So let's look at a couple of different types of questions that we might be asked. Right, so in the first one, I'm told, if K is greater than 1, which direction will the reaction proceed? All right, it turns out this is a trick question. I can't ask it, right? Comparing K to 1 doesn't tell me anything about the reaction direction. It tells me whether the reaction is product favored or reactant favored. So, that's a bad question. We can't even ask that question because I don't have enough information, right? Or someone might ask me, if Q is less than K, is the reaction product favored or reactant favored? Again, big fat no. I can't ask that question. The relationship between Q and K tells me which direction a reaction will go. It doesn't tell me whether it's reactant favored or product favored. The correct questions that could be asked related to this, if K is less than 1, is the reaction product favored or reactant favored? All right, that's an okay question. If K is less than 1, I know that's reactant favored. All right, and comparing Q to K does tell me about reaction direction. So this question is okay to ask. If Q is greater than K, which direction will the reaction proceed? All right, so if Q is bigger than K, Q is too big. So I've got too many products. So the reaction needs to proceed to the left. It needs to make more reactants. All right, so again, just to recap, comparing K to 1 tells me whether it's product favored or reactant favored. It doesn't tell me about the direction of the reaction. Comparing Q versus K does tell me about reaction direction, but it doesn't tell me anything about whether it's product favored or reactant favored. All right, so let's look at a numerical example involving the reaction quotient and reaction direction. Oh, and before I do that, I actually want to show a little tip that my general chemistry instructor taught me about remembering which direction a reaction goes. So if I write Q on the left and K on the right, I have to write them in this order for this trick to work. But what you can do is, right, turn my arrow into Pac-Man. Pac-Man goes to the right, So when Q is less than K, the reaction goes to the right, right? Or if Q is bigger than K, I know the reaction goes to the left. All right, now on to the example. All right, so we're given a reaction, and we're given its equilibrium constant. And then we're asked, first, is the reaction product favored or reactant favored? So in this case, K is definitely less than 1, and so I know that it's going to be reactant favored. All right, let's look at the next part of the example. Okay, so same reaction. Now we're told that in a particular experiment, we added 0.2 atmospheres of HBr and 0.01 atmospheres of H2 and 0.01 atmospheres of Br2. And I want to know, is the reaction at equilibrium? And if not, in which direction will it go to get to equilibrium? All right, so in order to do this, I have to calculate Q. So Q is equal to the concentration of H2 times the concentration of Br2 divided by the concentration of HBr squared. So if I plug in my numbers, I have 0.01 times 0.01 divided by 0.2 squared. And so I get a Q, when I plug this into my calculator, of 2.5 times 10 to the minus 3. So now I compare Q to K. So Q is bigger than K, so I don't have enough reactants or have too many products, and so the reaction needs to go to the left. It will make more reactants. Or I can ask Pac-Man, and he tells me the reaction will go to the left.